Hi everyone, how do we solve this tricky exponential equation? 7 to the power of k plus 7 to the power of 2k could be written as 7 to the power of k times 2 plus 7 to the power of 3k could be written as 7 to the power of k times 3 equal to 14. Let's continue. Now, let's 7 to the power of k equal to x. This implies that x plus x to the power of 2 plus x to the power of 3 is equal to 14. Let's continue. This implies that x plus s square plus s cube is equal to. Now, let us focus our attention on 14. 14 could be written as 2 plus 4 plus 8 because 2 plus 4, 6. 6 plus 8, that gives 14. Let's continue. This implies that x plus s square plus s cube is equal to 2 plus 4 could be written as 2 to the power of 2 plus 8 also could be written as 2 to the power of 3. Let's continue. This implies that. Now, let us move each of these constants to the left hand side. X plus square plus s cube minus 2 minus 2 to the power of 2 minus 2 to the power of 3 equal to 0. Let's continue. Now, let's rearrange this equation. We have x, this is minus 2 minus 2 square plus x to the power of 3 minus 2 to the power of 3 equal to 0. Nothing has changed. It's just a little rearrangement. It is possible we can put these guys in brackets. So we have x minus 2 in brackets plus. We can also put these two guys in brackets. X to the power of 2 minus 2 to the power of 2 plus. Likewise, we can put these two guys in brackets. X to the power of 3 minus 2 to the power of 3 equal to 0. Let's proceed further. This implies that x minus 2 plus. Now, recall that the derivative of 2 square formula, which is a square minus b square, is equal to a minus b times a plus b. If we apply this identity to this guy, we have x minus 2 times x plus 2 plus x to the power of 3 minus 2 to the power of 3 equal to 0. Let's proceed further. Also, let us recall another identity. It says a to the power of 3 minus b to the power of 3 is equal to a minus b times a square plus ab plus b square. So from this line, we have x minus 2 plus x minus 2 times x plus 2 plus. Now, let us apply this cubic identity to this guy. If you do that very well, we simply have x minus 2 times s square plus 2x plus 4 equal to 0. Let's proceed further. What do you notice on this line? You will notice that x minus 2 is common. X minus 2 is common throughout. We can factor it out. So we have x minus 2 into 1 plus x plus 2 plus this s square plus 2x plus 4 equal to 0. Let's proceed further. X minus 2 times. Let us drop each of these brackets. If we do that, we have 1 plus x plus 2 plus s square plus 2x plus 4 equal to 0. X minus 2 times. Let's add the common terms. We have x square plus s plus 2x, that is 3x. 1 plus 2, that is 3, plus 4, we have 7, equal to 0. Let's proceed further. This implies that x minus 2 is equal to 0, or s square plus 3x plus 7 is equal to 0. From this line, we have x equal to 2. Take note of this value of x. It is very important. Now, let us solve this quadratic equation using quadratic formula. X equal to minus b plus or minus square root of b square 4 times a times c divided by 2 times a. From this equation, a is equals to 1, b is 3, y c is equal to 7. Let's continue. X equal to minus, what is the value of b? B is 3. We have 3 plus or minus square root of b square, that will be 3 square minus 4. What is a? A is 1 and c is what? 6, 7. So we have into 1 into 7. Let's proceed further. Everything divided by 2 into 1. X equal to minus 3 plus or minus square root of, what is 3 square? 3 times 3, 9. Minus 4 times 1, that is 4. 4 times 7, 28. Everything divided by 2 times 1, 2. Let's continue. X is equal to minus 3 plus or minus square root of 9 minus 28, that is negative 19, divided by 2. X equal to minus 3 plus or minus, I can rewrite square root of negative 19 as square root of 19 times square root of negative 1 divided by 2. So x equal to minus 3 plus or minus square root of 19. Don't forget, from the complex number, square root of minus 1 is equals to what? Is equals to I. So we have I here divided by 2. This is another value of x. So take note of this guy too. But don't forget, our main goal is to find what? Is to find the value of k. So since 7 to the power of k is equal to x, let me show you where we got this condition. It's from this line. Let's proceed further. We will now consider each value of x. First, when x is equal to 2, that's the first value of x that we got. This guy. Let's continue. This implies that 7 to the power of k is equal to. So in place of x, we write what? We write 2. 2. Now, take log of both sides. If we take log of both sides, we simply have log 7 to the power of k equal to log 2. Recall that log a to the power of m is equal to m times log a. If we apply this identity to this, we have what? We have k times log 7 equal to log 2. Divide both sides by log 7. What do we have? We have k equal to log 2 divided by log 7. We can simplify this answer further by using this identity. It says log a divided by log b is equal to log a base b. So we have k equal to, applying this identity to this, we simply have log 2 base 7. This is the first solution. The value of k is equals to log 2 base 7. Now, let us consider the other value of x that we got here. Where is it? Okay, got it. So we are going to consider this value of x now is a complex solution. Similarly, when x is equal to minus 3 plus or minus square root of 19i divided by 2. So since 7 raised to k equals to x again, 7 raised to k is equals to x. This implies that 7 raised to k is equal to, in place of x, we write what? We write this value, minus 3 plus or minus square root of 19i divided by 2. Similarly, we take log of both sides. Log of both sides. So we have log 7 to the power of k equal to natural log of minus 3 plus or minus square root of 19i divided by 2. This left hand side is the same thing as writing k times log 7 equal to the right hand side log of minus 3 plus or minus square root of 19i divided by 2. Let's divide both sides by log 7 to get rid of this left hand side, this log 7. If we do that, we have k equal to log of minus 3 plus or minus square root of 19i divided by 2 over log 7. Also, we can simplify this right hand side further by using this same identity, log a over log b equal to log a base b. So using this identity on this right hand side, we have k equal to log of minus 3 plus or minus square root of 19i over 2 base 7. So therefore, all the solutions that we have for these tricky exponential equations are K equal to log 2 base 7. This is the first solution that we obtain. From here, we can obtain two solutions. K equal to, consider the positive sign, we have natural log of minus 3 plus square root of 19i over 2, close the bracket, base 7. And also, K equal to, if we consider the negative sign, this minus, we have natural log of minus 3 minus square root of 19i over 2 base 7. Let us label this equation, this answer rather. This is K1, this is K2, while this is K3. You will see that we have three distinct solutions in total. One real solution and two complex solutions.